Good evening, everyone. I hope you're all doing well. Today we are going to enjoy our third lecture in transport phenomena. This is heat and mass transfer, in case you guys don't know. So today we're going to learn about the underlying principles behind thermal conductivity, represented by K, as you can see over here. Now, there are going to be two parts to this lesson. The first part is just going to be a general overview of very seemingly trivial stuff. However, it's important to have these notes down in case you don't have them. Now, these are the units for K, represented over here. I wrote them down. And yeah, so let's start off with section A. Section A is just talking about the thermal conductivity in gases, liquids, and solids. Now, over here I wrote down the magnitude of the thermal conductivity and its dependence with T. Now, with gases, there's a linear dependence. With liquids and solids, there's a weak dependence. Now, over here, we are dealing with gases, and right now what I'm about to talk to you guys about is approximations for different thermal conductivities. Now, the reason we are trying to approximate thermal conductivity is because it's very, very hard to actually measure thermal conductivity. So the best thing that we can do is simply to approximate it. Now, a lot of these equations are almost 100 years old, but they are still important to know nonetheless, because they're the things that are in the most current and most up-to-date textbooks. Now, this is the equation for thermal conductivity in gases. Mn stands for your molecular number. This is your Leonard-Jones factor. This is your collision energy, and this is your thermal conductivity. Now, the reason I have the K over here is, well, you can just take it over to this side and square root the entire system. I do not know why the professor initially had a K on different sides. Now, with liquids, from the Sandler and Reed for organic liquids textbook, you can find the equation for K over here. TR, of course, is the reduced temperature, and the reduced temperature is given by this equation. Yep, and your TC values you can find from your typical Perry's handbook and whatnot. Yeah, so this is the reduced temperature at the boiling point. Here's the boiling point temperature, and then you have to find your TC values. And again, this is for liquids. Now, there isn't really much for solids, but also know that there is thermal conductivity for solids, and we're not really going to delve too deep into that. Again, this is a very short video, and this isn't the meat of the lecture. We will come back to the meat of the lecture the next video, part 2. Thank you.